Hi friends, let us discuss this Lrdi set on your screens. It appeared in slot 1 of CAT 25. It's not a very tough one, it's manageable, and I would want you to do it on your own first. So pause the video right here, try it on your own, and then look at the solution. Let's see what it says. A train travels from station A to station E, passing through stations B, C, D, E. The train has a seating capacity of 200. A ticket may be booked from any station to any other station ahead on the route, but not to any earlier station. All of this is obvious and self-explanatory. A ticket from one station to another reserves one seat on every intermediate segment of the route. For example, a ticket from B to E reserves a seat in the intermediate segments B, C, C, D, E. So it is like that. It goes like this. This is A, B, C, D, E, right? And the route is like this in this direction. What it says is that if somebody books a ticket from let's say A till D, so from A to D means the seat would be reserved from AB, BC and CD, all the segments, which is self-explanatory, which is obvious. So nothing new in this. This data is quite simple. Now, if you look at the next one, this is done. The occupancy factor for a segment is the total number of seats reserved in the segment as a percentage of the seating capacity. Seating capacity is already known. The train has a seating capacity of 200. The total number of seats reserved for any segment cannot exceed 200. I mean, they have clarified it, but again, quite obvious. So the number of reserved seats in any segment means A, B, B, C, any segment cannot exceed 200. 200 is the seating capacity. So all of this is like quite simple. The train starts from here, ends here, and these are segments A, B, B, C, C, D, D, right? A ticket from B to D, for example, would reserve the seat from B to C and from C to D. Everything is like quite clear. And then some information is given here, followed by a few questions. Let's look at the type of questions. What is the occupancy factor for this segment, right? How many tickets were booked from this? How many tickets were booked from this? And theta kind of questions, right? So we obviously, unless we figure out the numbers here, will not be able to answer these questions. So what I'll do is that, and we can just remove this and these questions from here and try and make something like this, right? So this is the route. I've just drawn it for you quickly. So this is how it goes. Starts from A and then moves in this direction, and the direction would always be like that, right? So what it says was you cannot book a ticket from D to C, right? So the direction is like that. So simple data again. Now let's look at the statements. What do they say? Segment CD had an occupancy factor of 95%. Since we already know the seating capacity, which is 200, and 95% means 95% of 200, which would be 190. So let's just write that CD 190 seats must have been reserved here. So I'll just write 190. So this is for CD, right? And what else is given? Only segment BC had a higher occupancy factor. So BC would be greater than 190. So that's what we know from this, had a higher occupancy factor, right? And let's just have a look at the rest of the statements. Exactly 40 tickets were booked from B to C and 30 were booked from B to E. Now tickets can be booked on multiple segments. So for example, you can book from A to B, from A to C, from A to D, from A to E. I mean, you can book any segment like this, from B to D, whatever. So what we can do is, because we'll need to figure out, looking at the questions, the exact number of tickets and occupancy factor and everything, I'll just write it separately. So if I have to just list the kinds of tickets that can be booked, they would be, so if somebody is booking from A, for example, so how many kinds of tickets can be booked from A? Can I say AB is 1, then AC, then AD, and then AE? These are the 4 kinds of tickets that can be booked from A. Likewise from B, how many kinds of tickets can be booked? Can I say the first kind would be BC, and then you can do BD, and then you can do BE, right? So it would be like this, from here till this stage, or from here till this stage, or from here till this stage. So if somebody books from B to E, it would reserve the seat for this segment, and also for this segment. Likewise is completed, there'll be just 3 more. So from C, one can book a ticket till either D or E. It would be, if somebody starts from C, I can just book a ticket like this, either till D or till E, right? And if somebody books a ticket from D, what is the only option available? D. Now we can just plug in these numbers. So when it says exactly 40 tickets were booked from B to C, we can just write that. So this is equal to 40, right? And 30 were booked from B to E. This would be 30. All right. And let's look at the rest of the data. Among the seats reserved on segment DE, exactly 4/7 were from stay. Okay, we'll come to it. What else is given? The number of tickets booked from A to C was equal to that booked from A to E, and it was higher than that from B to E. We'll come to it. Let's see if there's something easier. No tickets were booked from this. So the segment is AB, BD, DE. So AB, BD, DE were 0. So I'll just write this first. We should always plug in the easier data first. So AB, this is 0, and then BD, that would be equal to 0, and then it says DE, that is also equal to 0. Now you can see this, that there are 10 ways in which the tickets can be booked, and we have already got the numbers 5. This is 1, 2, 3 all known. This is 0, this is 0. So we just left with 5 of these. Likewise, this is left, and the rest all is given here. And let's look at this last statement. The number of tickets booked from any segment was a multiple of 10. Right. Now, the moment we read this, what we know immediately is that this would be 200. Why? This cannot exceed 200. This is occupancy factor. Right? So percentage cannot exceed 100. So the seating capacity is 200 given here. If it's greater than 190, what is the only option possible? If the tickets booked for any segment was a multiple of 10, the amount or the number of seats reserved in any segment cannot be anything else. It has to be a multiple of 10. So for example, if you talk about BC, what is this? The number of seats reserved in BC. It has to be some combination of the seats reserved or the tickets booked. So this 190 would be the sum of the tickets booked in multiple segments. So for example, AC would have a seat reserved for BC also, right? So if somebody books a ticket from A to C, that would include this segment BC as well. If somebody books a ticket from B to E, that would include this segment. But all of them are multiples of 10. So for example, with this, we can infer that this number here, this greater than 190, cannot be anything else but 200. So we cannot have a 192 or a 194 or a 197 here. So we can just replace this quickly with a 200. We've got this number, right? So this is 190, this is 200, and this is all concrete. Now, where do we go? We have used some parts of the data. Okay, let's now look at 3 and 4 that we had left. Among the seats reserved on segment DE, exactly 4/7 were from stations before C. Now, if you talk about this segment DE, so in how many ways can one book a ticket on DE, on this segment? So one is booking this directly DE, which has got 0 tickets. If one books from C to E, that would also cover DE. Just look at this. From C to E would cover this one, would cover DE. From B to E, DE, and from A to E. So, I mean, if you look at this, the benefit of or the use of writing it systematically is that you can clearly see that this segment DE is covered under these 4. Just look at this, these 4: AE, BE, CE, and DE. Right. So, likewise, if I ask you which all tickets start from A, you can say this is the segment. They all start from A. And which all end at E, because they only would cover DE, they were all these: AE, BE, CE, and DE. You can clearly see that these are the 4 that we are talking about here, right? So these are the ones. I'm just going to mark them so that you understand. So these are the ones that we are talking about. This, and this, and this. Fine. So they all include the segment D and no other ticket. Now, what is it saying? Among the seats reserved on segment D, which is not known to us, exactly 4/7. Now we know that all these numbers, fine, all this occupancy would be in multiples of 10 because tickets booked are also in multiples of 10. So even if we add a few of them, how would we arrive at the occupancy? By adding a few tickets booked for different segments, right? This would also be multiple of 10. Now this is a multiple of 10, and since it says 4/7, 4/7 is this 4 upon 7 into whatever is the number. So if it says exactly 4/7 of whatever is this number, when if I call it x, for example, so it would be like this. So can we say whatever this number is, whatever is the number of seats reserved here, and 4/7 of that has to be an integer? I mean, because these are number of seats reserved, this has to be an integer. Let's read it again. Among the seats reserved in segment D, I'm saying segment D, let's say X seats are reserved. Exactly 4/7 were from stations before C. Now this would be stations before C would not include C, E and D. So basically you're saying it's the sum of AE plus BE. It is like that. This would be equal to AE plus BE. Right? It is like that. Fine. And the rest would be CE plus DE. Now D is 0, the rest would be CE. Right? These are the four that we are talking about. But the important thing is, when you're talking about 4/7, can I say that X would be a multiple of 7? Only then it would be an integer. So if X is a multiple of 7 and X is also a multiple of 10, multiple of 10 we already know, fine, because a number of tickets booked in any segment is a multiple of 10. So X is both a multiple of 7 and a multiple of 10. So what are these numbers? Multiple of 7 and multiple of 10. Multiple of 10 means 10, 20, 30, 40. And multiples of 7, 7, 14, 21. I mean, you can talk about LCM or you can do it commonsensically. So can we say that X would be a multiple of 70? There is no other possibility. So if X is a number of this form, 70, 140, 210, etc., etc., then only it's going to satisfy this condition. So if X is 70, then it is a multiple of 10 as well as a multiple of 7. So it will give you an integer. Likewise, it can be 140, it can be 210. Now this 210 is not possible because 210 is greater than 200, isn't it? So the seating capacity of the train is 200, it cannot be greater than 200. So what are the only two options possible for this X? It can either be 70 or 140. Now we can see this, what will happen? Let's say this is 70. If this is 70, what would be this number? 4 upon 7 into 70. So that will be 40. So you're saying that AE plus BE is equal to 40. So this is the condition. Now if AE plus BE is equal to 40, this BE is already known to us, this is 30. So what would be AE? AE would be equal to 10. Now the issue is that if you look at this fourth statement, the number of tickets booked from A to C was equal to that booked from A to E. So this is basically equal to this. And it was higher than that from B to E. So what it says, statement 4 says that AE has to be greater than BE. Now BE is 30, so AE cannot be 10. So what it means is that this is incorrect. If this is incorrect, then what we are saying is that this is incorrect and then this is incorrect. Now, if this is incorrect, this X70 is not going to work. So what would be the value of X? There's just one possibility. X has to be, or this occupancy here, number of seats reserved on this segment DE has to be 140. There is no other choice. So we can just replace it this 140. This is concrete logic. So this becomes 140. If this is 140, now when you're calculating this 4/7 of X or 4/7 of, now this becomes 140. It is like that. You don't have to write all this just for understanding. So this is like that. Now how much would this become? This would be equal to 80 now. So this becomes 80 and this 80 is good here. If this is 80, what is this? This is AE plus BE because it's talking about 4/7 were from stations before C. So stations before C means you cannot take say CE and DE. You can only take AE and BE. There were just 4 ways: AE, BE, CE and DE. So CE and DE would be stations starting from C and afterwards, and stations before C would just include AE and BE, the way it's written here. So AE plus BE becomes 80, BE is 30, this BE is 30. So what would be this AE then? Can I say 80? I'm saying this BE is 30, right? If this is 30, and what would be the value of AE? AE would become 80 minus 30, which is 50. So we can just replace that then. And what we can also write is the number of tickets booked from A to C was equal to that booked from A to E. So A to C is equal to A to E. So this is 50. Then how much would this be? This would also be 50. You can just write that as well. So both become 50 here. Now when we've got this 80 here, fine, which is the sum of these two, you've got the sum of these two as well, because this segment DE would be covered in these 4. Look at this line. So AE, BE, CE, DE. So this is total 140. 80 is already gone. This 80. And the rest would be, if I have to just write it, I can write that as well. 140 minus 80, that is 60. Right, that's 60. Now we could have done it like 3 upon 7 into 140. That would also have been 60. But what we know is that this 60 would be the CE and DE, the sum of CE and DE. the way this 80 was the sum of AE and BE, because there are just four, AE, BE, CE and DE, four kinds of tickets that would include this segment DE, right? So two are already gone. This is 0. Where would this 60 go? It has to be this. So we make this 60. And now we can remove all this. This is not really needed. And we've got quite a few numbers here. We can just, when all this is also not needed, we can just remove this and proceed with filling the rest of the data here. Now, if you look at this part here, we have got this 200, 190. We can make use of this and fill up the rest of it. So, for example, if you talk about this BC segment, this is 200 seats reserved. Which all tickets would have this segment BC? Which all kinds of tickets? Can I say from A to B would not have it, but from A to C, from A to D, from A to E, they would all have this segment BC. Likewise, starting from B, which all would have this segment? Anything that starts from B. So BC, BD, BE. If you look at this structure here, where is this segment included? I'm just going to mark this for you so that you can start visualizing it like that. It is this segment. So if you look at this part that I've highlighted, all of them have got this 200 included, isn't it? I mean, anything that starts from A and reaches at least C. So AB is not included. So I've excluded this. Now AC, AD, AE. So AC, AD, AE. This will add this 200. And anything that starts from B. So BC, BD, BE. You just don't make a mistake in this silly one in this, and then you'll be all right. Now all these tickets should add up to 200. So how much is this? This is 4, 40, 30, 70, 70, and this is 100, 170. So how much should be AD? Can I say the sum of all this subtracted from 200? So if I write this, that which is 30, then all this should add up to 200, and which should be the case. So what have I done here? I'm just writing this. What is this? This is 200 minus the sum of the rest of them, because the number of seats reserved here on this segment can be done in one of these 6 ways. A to C, A to D, A to E, these 3, and then B to C, B to D, B to E. They all would contribute towards the reservations on this segment BC, right? So 40 plus 30, 70 plus 50 plus 50 is 170. Subtracted from 200 and you get this 30. So we have done this. Likewise, you can do it for the rest of the segments as well, and it's all okay. Now, if we have done this, we can just write one more thing here. I'll just remove this. Then I'll show you. This is left still. I don't know if it will be used or not, but we can simply fill it. So if we talk about AB, what all other tickets that would reserve something here on AB? What all are the kind of tickets? Can I say AB can be reserved only on the tickets that start from A? Now, if you look at this, which all are the kind of tickets that start from A? Anything that starts from A would book a ticket on AB or reserve a seat on AB. So AB, AC, AD, AE, they all would contribute. So it's the sum. I mean, if I have to just write it, this is all going to give you a reservation on this segment AB. You book from A, go to B, book from A, go to C. And anything is going to give you a reservation on AB. So what would be this number in case this is R? This will be 50 plus 30 plus 50, and they'll become 130. Right. So this is again simple. We can remove this. And what is left in this now? If you look at this, we filled everything up except for this CD. Now this CD would be included. Now we know the number of reservations on this segment, which is 190. And we just have to calculate the way we did with this 200 and calculate this AD. Where all is this segment included? CD. Where all? So it would be included in this. If you start from A, where all would it be included? If you look at this, now I can mark this, or let me just mark this for you. This is the segment. So it would be like that. If you look at this, and can you look at the symmetry here? If you write it properly, then this happens. It is like that. So if you go from A to D, CD is included. You go from A to E, CD is included. AD, AE. You start from B and you have to include CD. So you have to at least go till D. So this is BD. Or you can go from B to E. This is there. You start from C. So you take a ticket of CD. It's included 190. Take a ticket from C till E. Then this is also included. So what does it mean in essence? The sum of these 6 now would add up to 190. Now how much is this? This is 30, 50, 80 plus 30, 110. and this is 60, this is 170. So 170 subtracted from 190 is going to give you the value of CD. How much would that be? 190 minus 170, this becomes 20. You don't have to draw it like that the way shown you, but what I was showing you is symmetry. If you write it properly, then it becomes symmetrical, and there is no chance, zero chance of you doing a silly mistake here, making an error and missing out on an easy question like that. So these six kinds of tickets are going to get you a reservation in the segment CD. That is basically the meaning. So start with one of them and then you can do it like that. You don't have to just mark it. This is just for explanation. Now we have done this and we can just answer the questions very quickly on this. Let me show you the questions here. What do they say? What was the occupancy factor for segment DE? DE is this 140. So that's basically 140 upon 200. 200 is the seating capacity of the train. So DE is 140 occupied out of 200. That will be 70%. That's basically 140 upon 200 into 100%. So this is the calculation that we did here. Okay, how many tickets were booked from station A to station E? Now it's very clearly given here. We have calculated everything. So that's the use of writing everything systematically. So that's 50. This 50. Okay, how many tickets were booked from station C? So station C, how many tickets would be booked? We have again written systematically. So this starts from C, this starts from C. So CD plus C, this is 20 plus 60, this becomes 80. That is your answer here. And the fourth one, what is the difference between the number of tickets booked to station C and the number of tickets booked to station D? Station C, the tickets that end at C. So where would they be? This is AC, this is BC. Fine, 50 plus 40. These are the two kinds of tickets that end at station C. So there will be 50 plus 40. And if you want, I can just write it like that. And then this would be number of tickets booked to station D. Station D means AD is 30, BD which is 0, and then CD. So 30 plus 0 plus 20. You won't write it in an exam. It's just for explanation. So how much is this? This is 50, 50 cancelled. This becomes 40, which becomes your answer to the question. Write this simple again. And the last question, how many tickets were booked to travel in exactly one segment? Again, that's very, very clearly visible here. One segment is this, A, B, B, C, C, D, D. So you have to sum them up. How much is this? 0, 40, 20, 0. So 40 plus 20 basically. So this is 60. Right, so we've got all the 5 answers like pretty quickly, and this would have given you 15 marks in the exam. Wasn't very difficult. The only challenge here, the only thing that you could have kept in mind while doing a question like this, which I'll call pretty manageable, would be just write the data systematically. Otherwise, you might end up making a silly mistake here. Right, so this is it from my end for now. Hi friends, let us discuss this Lrdi set in screens. It appeared in slot 1 of CAT 2025. If you've not seen this, not attempted it, pause the video right here and try doing it on your own first. That's how it's going to optimally benefit you. Let's see what it says. A round table has 7 chairs around it. The chairs are numbered 1 to 7 in a clockwise direction. Simple data. For 4 friends, A, B, C, D sit on 4 of the chairs. In the starting position, A and C are sitting next to each other, while B and D, there are empty chairs on either side of the chairs that they are sitting on. Simple again. The friends take turns moving either clockwise or anti-clockwise from the chair. Okay, and the friend who has to move in turn occupies the first empty chair in whichever direction he chooses. So if you are moving in clockwise direction, you occupy the first empty chair. Anti-clockwise direction, same thing. Right, and then the order is given. A moves first, that's the first turn anybody takes, followed by B, C, D. Okay, so it's good that it's given in alphabetical order only. So first move is made by A, then second by B, then C, then D, fifth, then the cycle continues. So it's like A, B, C, D, and then again A, B, C, 7 turns they are saying, 7 moves, 7 turns, right? Following information is known. The questions are like, what is the number of the chair initially occupied by Bashir? Who sits on the chair? Okay, okay. So again, we'll have to track the turns. It doesn't look too difficult. This is about turn 3, this is turn 6, turn 7, and this is about the initial arrangement. So what we'll do is, we cannot answer these questions without making something. So I'll just, if you've done this, make a small circle kind of a structure and we can do this. Now, if you look at this, there's not too much data and we can just simply start filling in. Let's look at the statements. The 4 friends occupy adjacent chairs only at the end of turn 2 and turn 6. So let's assume that this is the starting position, the initial position, and then there'll be 7 moves like that. Okay, so if I have to just write it like that, I'll just put it this way. Though this is nothing much, it's like, it says 1A, then 2B, then 3C, then 4D, then 5A, then 6B, and then 7C. It's like that. It's all given, but I've written it separately just for understanding. What does that mean? That the first move is made by Aslam, A, second by B, Bashir. It goes like this, then C, then D, then A, B, C. It goes like this, 7 turns only. So after this, we do not have to look at any of this, just these 2 statements. We cannot use statement 1 here, so let's leave it alone. 2 says D occupies chair 2 after turn 1. Now, can I say that if D occupies chair 2 after turn 1, then initially also D must have occupied chair 2? There is no other possibility. What is the reason? In turn 1, who moved? Now, that's the reason I've written like that. And if you have to look at any turn, you can just simply straight away look at this, and there is no scope of making any silly mistake here. After turn 1, only A changed the position, right? Rest all keep sitting like that. So if it says D occupies chair 2 after turn 1, can we say that even before turn 1, D must have occupied chair 2 only? So initially, D must have occupied chair 2 only. There is no other possibility. So I'll just put D here. Right. So that is the only possibility. D must have been at chair 2 initially, and then after this turn 1 movement 1 happened, since D did not change position, only A changed position. So D then again was at chair 2 after turn 1. So it must have been like that. Likewise, if you look at, this is a later turn, turn 5, and D must have made 1 movement by turn 5. This is turn 5. So D must have made this 1 movement, right? But if you look at this one, Chavi, C occupies chair 7 after turn 2. Now, when is the first time Chavi or C made any movement? It is this third turn, and this is the number of turn, first turn, second turn, third turn. So this is turn 2. So C occupies chair 7 after turn 2 means C must have started with chair 7 only after turn 2. So C is at 7 after turn 2. It means that C would be at 7 initially also. There is no other way, because C makes the first move in turn 3. So C at 7 after turn 2 means C at 7 initially also. So we can put this as C. Pretty simple. Now we can use the data that was given initially. What was given? In the starting position, A and C are sitting next to each other. So A can be here or here. And while for B and D, Bashir and David, there are empty chairs on either side of the chairs that are sitting on. It means that if D is here, this would be empty and this would be empty. There is no other way. 1 and 3 would be empty. It means if they are sitting beside each other, A and C, what is the only possibility? Can A come here? No. Then it would violate the condition, because if D is here, this and this would be or should be vacant. So it means that if this is C, then the only possibility of A is this. So let me just put A here. If this is A, again, what's the only position left for B, Bashir? Now, Bashir cannot come here, cannot come here, cannot come here, because Bashir has both the neighbors' positions empty. So the only possibility is this. So this becomes B. Can you see this now? This satisfies both the conditions. Let's just read it again. Starting position, A and C are sitting next to each other. So A and C are sitting next to each other. While for B and D, there are empty chairs on either side. So you can see D, empty chairs here, B, empty chairs here. So this is our initial position. right? And after that, we just have to, because there's not much here, we've written this as a very small, very simple question, I would say, and we have used this statement. What is left in this? If you look at this statement one is left to be used, and this part, D occupies 4 after turn 5. This is to be used, nothing. Now there are two approaches here. One is that if you want to do not, if you're not keen on drawing it again, the structure, then you can just answer the questions from here itself. You can do that, right? Another way is that you draw separate structures so that there is no confusion. So the way I'm going to show you is by drawing a new structure for every turn. It might take a couple of extra minutes, but you'll be 100% sure you will not make a silly mistake. You can try doing it here also, and you can answer the questions accordingly. Then that's possible. You can do that, right? But here there'll be a small chance, I'll explain later, that you might mess up somewhere in an easy question. Might just lose marks in that, which is not advisable. So what I'm doing is that I'm making a parallel structure for the turns there. So this is the initial position. So what I'm showing you now is a new structure. This is for turn 1 or after turn 1. This is initial, this is turn 1, then we can make it for turn 2. Will not take much time. 10 seconds you can draw a circle, number the positions like that, and then see. So how do we move now? If you look at this part here, this is the initial position. This would be after turn 1, that will be after turn 2. Now who would move in turn 1 and turn 2? This is initial. And what do we know about turn 2? There is just one condition. They would be at adjacent positions. Fine. Now if we have to get them together by moving just A and B, think about that, because it says they occupy adjacent chairs only at the end of, just leave the only part. We have to somehow get 4 of them together after turn 2. You've got 2 moves left, one for A and one for B. Look at this, their positions, and tell me or think, how can they be together after one movement of A and one movement of B? Let's say I move A here. Fine. If I move A here from 6 to 5, that is anti-clockwise direction, there will be no possibility of getting 4 of them together after one movement of B. You can just visualize it quickly. Let's say A comes here. I'm just going to show it to you here only. Let's say this is the position of A after the movement. Now A moves from this position. Fine. So this is gone. Now C and D are at 7 and 2, and A and B are at 5 and 4. How is it possible that one movement of B can get all of them together? Not possible. So what is the meaning? That A cannot move in this direction, counterclockwise direction. A has to move in the clockwise direction. That is the only possibility. So if A has to move in the clockwise direction, now we can arrive at our first iteration here, first configuration. So A would land where? A starts in clockwise. So 6, 7, and this is the only possibility. So we can just write it like that. C remains as it is, A moves here, D remains as it is, and then B goes here. And now you can clearly see, so this is after turn 1, this A moved. You can clearly see what we are expected to do now. Since we have to get them together by moving B, now this looks possible. If A had moved here in counterclockwise direction, it would not have been possible. But here, now A moved here. If we move B to this position 3, which is again counterclockwise, this would be possible. So I'm again drawing it. You can just keep drawing them. They're like very simple, will not take time. This is C, this is A, this is a T, and B moves where? B is at 4. Where would it move? To 3. So this is right. So which turn is this now? This was initial position. This is turn 1, and this is turn 2. You've got this. Turn 6 would come later. Which statement would we use now? We have to go from turn 2 to 3, then 4, and likewise we are expected to continue. Look at the statement second. This second statement says D. We have already used this. We have used this. Only one statement left. D occupies chair 4 after turn 5. Chair 4 after turn 5. Now, if we talk about turn 5, this is till turn 5. How many times does D move? Just once. So can I say if D occupies chair 4 after turn 5, even after turn 4, D must have occupied chair 4? You get the point. D moves in the first 5 turns only once. Where is that? It is this. That's the reason I wrote it separately. Fine. 4D. So turn 4 makes D move. So if D is at chair 4 after turn 5, can I say D would have occupied this chair 4 after turn 4 itself. That is the only possibility. Now we are at which turn? We are at turn 2. And this was turn, this is initial, this is turn 1, this is turn 2. So we have to ensure that D can occupy chair 4 after turn 4 or in the 4th turn, right? Now, but before that C comes. Now C has got how many options? C can either move here in this direction, this is counterclockwise direction, and from 7 can come to 6. And let me just show you the next one. This is after turn 3, which is C's turn. So A and D and B, they would remain like that. And so I'm just going to put them like that. This is A, this is D, and this is B. They're not going to move in turn 3, right? Only C can move. Now C has got two options. So C can either go to 6 by moving counterclockwise, or C can go from here till here. Fine. Where would it land then? 4. So if I make C move clockwise, then C would end up at 4 here. So this is like that. This is after turn 3. But the problem would be if C comes here, now C is not going to change position till turn 7. So it means D would not be in a position to occupy chair 4. So it means what? We cannot move, or we cannot make C move clockwise. We have to make C move anti-clockwise, because we have to create scope for D to occupy chair 4, which it has to, right? So it means what? This is incorrect. Fine. It cannot go like this. So C from this place here has to come here. So I'm just putting C here. So this is C and C goes from here. So this is after turn 3 now. This is initial, turn 1, turn 2 and turn 3. And now if we look at this here, because D is the only one who would change position in turn 4. So can I just simply copy ACB here? Yes, we can do that. So A remains at 1 and then C remains at 6 and B remains at 3. Now see what will happen with D in turn 4. This would be turn 4. So D now has to come to 4th position. Fine. If D comes to chair number 4 in turn 4, then only D can be at chair number 4 after turn 5, right? This is the only thing that you had to figure out. D at 4 after turn 5 means D move to 4 in the 4th turn, right? So this is the position. Now D is here, can go here. This is one step in the clockwise direction, because B would skip chair 4. This is already occupied by B. So D would skip this over B and would from 2 move to 4 in the clockwise direction. So let me just write it like that. This becomes D. Right. So this is now turn 1, turn 2, turn 3, turn 4, D moved. And we are done till this stage. Now we have used all of this. So what would we use? Just one piece of data left now. They occupy adjacent chairs after turn 6 as well. So where are we? I mean, if you're confused, let me just write numbers. So this would be 1, this would be 2, this would be 3. These are turns. I'm writing the number of turns. This would be 4. And now what I'm showing you would be turn 5. This would be turn 5, right? These encircled numbers are turns. This is turn 1, turn 2, turn 3. This is the original position. It's turn 4 and this is turn 5. And the only, we do not have a condition for turn 5. We have a condition for turn 6 that these 4 have to be together. If these 4 have to be together, where can we make them move? Now in turn 5, turn 6 were expected to move. Turn 5, turn 6 would be A and B. Again from this position, by making A and B move, we have to get them together. So where should A and B move here? And if you look at this, this is A. Now if we make A move here, fine. Just visualize this. Let me just copy the data as well here. This would be C, this is B, and this is D. And this is A's move, 5th turn, right? Now in this 5th turn, A is here. So if A moves here from here to here, just think about that. Let's say we make A move here. If we make A move here, what would happen? Now in the 6th turn, it's B's move. So where can B go? B can go either at position number 5 over D or here. But in both the cases, all these 4 people would not be together. So what does that mean? A moving clockwise from 1 to 2 is not going to give us the desired result. So it means that this is not right. What is the only other option? That A goes from here to here in the anti-clockwise direction. 6 is occupied by C and A comes at 7. So here it would be A then. If this is A, we remove this from here, and that's the possibility. Right now, if you look at this, A at 7, C at 6, 5 is vacant, fine, and then this is B. So what would happen in sixth move? Sixth turn is B's turn. B moves clockwise from 3, jumping over D would move to this position, and this gives us the desired result. Fine, that's the last condition that we had. And what would happen? A at 7, and this is at D, and this is C already. Fine, and the movement would happen of B in clockwise direction. So skips this and occupies this. So this becomes B. And this is what? This is, these encircled numbers are turns. So this is the sixth configuration. Original 1, 2, 3, 4, 5, 6. And for the seventh one, if you look here, there is nothing given. Nothing given over here for the seventh one. So seventh would be for C. If you look at this, I'll just put it like that. So A would remain intact, and then B would be here, and then D would be here. And this is number 7. This is number 7. Where can C go? C can either go here, fine. In this place, I don't think there is a problem because there are no conditions. The only real condition given here is the 4 friends occupy adjacent chairs only at the end of turn 2 and turn 6. So C has to move. So C can go from this place to this place. I don't see a problem. So is it resulting in any kind of violation? No, not really. A, C, B, D, no real problem. This is all okay. Or C from the 6, if C prefers to move in this direction. So C can go here clockwise. So from 6 to 1, this is fine. Or from 6 to this position, this also looks good. I believe both are possible. So C can either go here or here, even if C occupies this 3. So let me just call them what? This is C1 and this is C2. This is for our understanding only. So this is the first position possible for C from here to here, 6 to 1. Fine, this is clockwise, jumping over A, and in this direction, jumping over B and D, C would land at 3. So here A and then B, D, C. No problem with this setup. Or it would be C at 1, A at 7, B at 5, and D at 4. Again, no problem. So this is the final one. So we've got everything here. I would suggest that you do it like that, because if you do it in one structure, this is possible, you can answer that. It might still create some problem and you might lose out on some easy marks. So this is all what we have. Original 1, 2. This is original. This is after turn 1, after turn 2, then 3, after 4, after 5, after 6, after 7. And you can draw it like really quickly if you do it like that. So I'll just remove all this. Is not really required here. And let me just show you the questions very quickly. So it is like that. What is the number of the chair initially occupied by B? So this is 4. So fourth, we get it from here. So this is the chair number of B initially. Who sits in the chair numbered 4 at the end of turn 3? Now you'll understand what I was saying earlier. We could have done it like that. This question is for the original one and the initial configuration. We could have answered that from here. Now this is about turn 3, this is about turn 6, this is about turn 7. So what you could have done is that in a single setup, you just keep looking at the questions and keep changing the positions. That was possible. But again, in an exam, we might not be in a position to optimize the solutions like that. So I would say just draw everything. Might take a couple of extra minutes, but these are solid 12 marks for you, right? Let's answer this. Who sits in the chair numbered 4 at the end of turn 3? Now you know these turns are marked. Everything is written very neatly. This is the end of turn 3. Who sits on chair numbered 4? Where is chair numbered 4? Chair number 4 is vacant, right? So answer becomes option D, which is no one. All right. Which of the chairs are occupied at the end of turn 6? Turn 6. This is turn 6. Which chairs are occupied? So 4, 5, 6, 7 are occupied. 4, 5, 6, 7 is option A, right? So once we have done it like that, we can just answer it very quickly, and there's like absolutely no scope of getting anything incorrect. Just last question now. Which of the following best describes the friends sitting on the chairs adjacent to the one occupied by B at the end of turn 7? Friends sitting adjacent to the one occupied by B at the end of turn 7. So this is B and this is turn 7. So adjacent to B, so C is either at 1 or at 3. So who is beside B or who is adjacent to B at the end of turn 7? So it's D. Look at the options. Best describes the friend sitting on chairs adjacent. So that's D only. So whether it's option 1 or option 2 or case 1 or case 2, C is either at 1 or 3. A is fixed at 7, B is at 5, and the only neighbor of B at this stage is D, who is at 4. So answer would be D only, that is option A. And you got all of 4 answers. The only thing that you could have optimized in this question is by doing it in a single setup. And in that case, you have to be careful about it, that you answer the questions in order. So I draw this, and on this only I answer the first question, then I answer the question about turn 3, then turn 6, but it might create some confusion. So if you want to be sure about these 12 marks, that's the way to go, and that's like not going to take much time. It'll be pretty simple, right? So this is all what I had for you. I'll see you again soon. Goodbye. Hi friends, let us discuss this Lrdi set which appeared in slot 1 of CAT 2225. It is different from other sets that appeared in the slot because this is pure data interpretation. There is not much use of logic or logical reasoning here, and this is something that's very rare in CAT these days. So most of the sets are dense in logic these days. So this can be like a relief for people who are not very comfortable solving puzzles. This is not very difficult. So if you've not done this, not attempted this, you can pause the video right here and do it on your own first. Otherwise, you can discuss this. I'll just show you the question also to complete. So this is the data, and these are the 4 questions. You can either take a screenshot, click a picture, or whatever. But using this data, you have to answer these 4 questions, right? So you can just look at this and solve it, and then watch the solution. Let's see what it says. 5 countries engage in trade with each other. Each country levies import tariffs on the other countries. The import tariff levied by X on Y is calculated by multiplying the corresponding tariff percentage with the total imports of country X from country Y. Self-explanatory, simple data. So there's a rate of tariff that a country levies on another country, right? And that would be in percentage, and whatever is the total value of imports, a percentage of that goes as import tariffs. That is what it says. The radar chart below depicts different import tariff percentages charged by each of the 5 countries on the others, and this radar chart shows the import tariffs percentage, right? And they have given an example as well. Just to explain, this makes it simpler. US, the blue line in the chart. So US, this is blue line. They've explained how to read this chart, which is good. So this is the line that we're talking about. This is blue line, this is blue line, right? And here, I think this red line or this maroon line, whatever you call it, I think this is superimposed on it. So it's not visible, but it's clear that it moves like that. So from here to here, then it goes here, and then it goes here. So this is the blue line, this is the US line, right? And they have given example. US charges 20%, 40%, 30%, 30% import tariff percentages on imports from France, India, Japan, and UK. So what it means is that if something is exported to US, or in other words, if US imports something from these countries, France, India, Japan, UK, and they're given in this order: France, India, Japan, UK. And what do you have to look at? This US, this blue line. So this blue line, if the import happens from France, India, Japan, UK, the percentages would be like that. You can just look at this. So for example, if you look at this point, what is this point? In this radar chart, you can see this is 10%, 20%, 30, 40, 50. So here it will not be written everywhere, but this would be 10, this would be 20, then 30, then 40, then 50. If you go to this, then this would be 10, 20, 30, 40, 50. If you go to this one, 10, 20, 30, 40, 50, and likewise it continues. So you just have to read it very carefully. So if you look at this blue line here, what does it show? If you look at this France, so first of all, you will look at this US, right? And if you talk about France, what does it say? France is at 20%. You can see this 20% here. And this is France. Blue line, where is it towards France? Here. So this is that 20%. If you look at India, this is the blue line. This is India. Where is it? This is, if you just have to look at it, 10, 20, 30, 40, 50. Or What you can also do is when it's on the higher side, look in the reverse direction. This is 50, the highest. So this point would have been the highest for India, which is 50. It is one less than that. So that becomes 40% or whatever. It shows that at 40%. Let's do one more. This is Japan. Japan is 30%. Right? This is Japan and this is Japan, 30%. So look at blue line. So this is blue line here, right? This point. So where is this? 30%, 10, 20, 30, or you can do it like this, 50, 40, 30. And the last one also, this is 30%. This is UK, 30%. This is UK, blue line. This blue line, you can again see 30%, 50, 40, 30. So this is exactly the point, then 20, then 10. So 10, 20, 30. So this is very clear that US charges 20, 40, 30 and 30% respectively for imports from France, India, Japan and UK. So likewise, you can read it for anything. So for example, if India imports something, now we're talking about India importing, we were talking about US importing then. So India is this green line, so this is the green line. So if India imports something from France, fine, where would this be? This is green line, France is this, so green line, where is it ending? 50%. So India would charge 50% of the value of that shipment as the import duty, like that. And this is like very simple. If you look at this bar chart, what does it show? The bar chart depicts the import tariffs levied by each country on other countries. So here it is in percentages. Here they are absolute values given in billion US dollars, right? And यहाँ for example इसका भी दिया हुआ है. For example, US charged import tariff of 3 billion USD on UK. So US charged import tariff. This is US, an import tariff of 3 billion USD on UK. You can see this. Where is UK and this? If I have to just look at this one, then UK is this black one. I'm looking at this US. This black one is UK here. So you can see this at 3. So if something comes into US, I'm talking about US imports. Fine. So if you look at this France, it'll be $6 billion. If you look at this India, so US imported from, or US levied import tariff of, you can see this $4.5 billion on India. On Japan, it'll be 7. On UK, it'll be 3. And this is what is given here. So you can just read it easily. There's nothing in this. Let's just read this part as well. Assume that imports from one country to another equals the exports from the latter to the former. So if India is exporting something to Japan, so that becomes India's exports to Japan, or we can also say they are Japan's imports from India. But here this whole thing is given in the context of an importer, an import tariff percentage, import tariff. So it would be good if while doing the calculations or while looking at the questions, we think of in terms of the importers only. So this part is clear. The trade surplus, now this is something that as MBA aspirants should know what is trade surplus, trade deficit, but still they have given the definition. The trade surplus of country X with country Y is defined as follows: exports from country X to country Y minus imports to country X from country Y. So if you are exporting more, it's a trade surplus. So for example, if India exports to France goods worth 10 billion US dollars and imports from France goods worth 8 billion US dollars, then there will be a trade surplus of 2 billion US dollars. And what it finally says is a negative trade surplus is called trade deficit. Whereas if it's the other way around, when you are importing more and exporting less, then it's called a deficit. So a negative trade surplus will be called a trade deficit. Simple definitions, should otherwise also know from general knowledge. This is important for you, but not sure, they have given the definition. You are exporting more to a particular country as a country. You are exporting more and importing less. You enjoy a surplus with that country. When it's between a pair of countries. You are importing more but exporting less. Importing more and exporting less. You have a trade deficit. This is what it says. So if you've understood this data, there's nothing in it, and then we can go to the question straight away. These are 4 different questions. This is a very, very simple one. What does it say? How much is Japan's export to India worth? Now, as I already said, they're talking about Japan's export to India. If it's Japan's export to India, how would you think India's imports from Japan? We can think of like that because everything is given in terms of importers, right? So this is Japan's export to India can be thought of as India's imports from Japan. Now, India's imports from Japan. How much is the duty levied or how much is the import tariff? where do we go? We go here. We go to this India. When we go to India, where is Japan? Japan is this. This is India and this is Japan. So when we talk about India and Japan, in this India, Japan is this yellow one, right? Where is it? This is India and this is Japan. Can we say that it looks, this is between, just look at this, draw an imaginary line, think of this as 3 and this is 4. So where does this bar go? In India, this yellow bar is Japan, and you can see that this is 3.5 billion US dollars. So I'm just writing this. It is like that. This is 3.5 billion USD. Or you can just, you don't have to write that. Now, this is the import tariff in US billion dollars, absolute value. Now, this would be some percentage of the total goods or the total imports. What percentage? Now, where do you go? You look at India's import tariff in terms of percentage. So, import tariff percentage. So, this is India. This is the green bar. And the green bar, and what would you look at? Japan. So, India, green bar. This is the green bar, India, right? And where is Japan? This is Japan. So, how much is this? This is 50%. In fact, if you look at the other one also, Japan also levies an import tariff percentage of 50%. It happens in so many cases. You can see this yellow bar when it ends at India with a 50%. But we're not looking at that. So don't be confused. When you're talking about Indian imports, which is the case here, you look at this green bar, and it ends at Japan here, right? So this is 50%. So basically what you're saying is 50% of the total worth of goods would go as import duty or import tariffs. So how much is this? This is 3.5 billion USD, which we found from here. This is India, Japan, yellow bar. This is 3.5. So 3.5 should be 50% of the total imports. You got this? So how much would be the total imports then? Into 100 by 50. Or you can just think of it like this is 50%. If this is 50%, what is the worth of the goods? What is the worth of the total imports of India from Japan? Or what is the worth of the, in other words, the total exports from Japan to India? Total exports of Japan to India or total imports in India from Japan? It's the same thing. So that will be equal to 7 billion US dollars, which is option B. I spent some time here because when the data here, though they've explained it, might confuse some people because some people found it a little time consuming, cumbersome at the time of exam, and you can see this is actually quite simple. When we arrived at this 3.5 billion USD, we just had to realize that this is nothing but 50% of the total value of the goods. So you do not need any calculations. $3.5 billion is 50%. So what would be 100%? That would be 7 billion USD. This is what it says. And this is question 2 for you. This is which among the following is the highest? Imports by France from India. So France is the importer here, India is the exporter. What should we look at in the chart? France. We're talking in terms of importers here, as I already explained, right? So importer France, this is France. What would you look at? India's bar. This is green. So France, green. This is the level. So where is it? Between 6 and 7. This looks like 6.5. So I'll write 6.5 here. Now, what is the percentage when France imports something from India? So France is this red one, a red line here, and India is this. So red line, this one, it ends at India. How much is this? This is 40%. How? 10, 20, 30, 40, 50. This is 40%. So basically, this 6.5 billion USD that we found here is 40% of the total worth of goods that are exported from India to France, or that are imported in France that have arrived from India. So this is 40%, 6.5. So what would be the total worth, or what would be the total imports by France from India? There will be 6.5 into 100 by 40. This is simple. 6.5 is the rate is 40% when something is imported by France from India. How do we look find this? By this chart. This is France, red one, this is India. So this is the number, right? You already know that. So this is 40%. And what is the absolute value in billion USD? That is from here, France, and this is India. So India, green one. Under France, if you look at the import tariffs in US billion dollars levied by France on Indian goods while importing, that comes to 6.5. So 6.5 is basically 40% of the total value. we can just do it similarly for rest of them. 6.5 into 100 by 40. Would I calculate it? No, because I just have to compare. Now imports by US from France, by US. US, where is France? This red one. So this is US, France. How much is this? This is 6. So I'll write just 6 here, right? Where would I go now? This blue bar, US, 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 US. And where is France? This is France. How much is this? This is 20%. You can see this 10, 20. Blue, this blue line, and this is France, right? So this is where we're looking at. So this is how much? 60 into 100 by 6 into 100 by 20. You can compare them without writing as well, but I'm writing all the 4 values. This is pretty simple. We'll not calculate, we'll just compare. Now you can clearly see, for example, in these, which is the bigger one. Now, obviously this is bigger. We have not checked these two, but this is bigger than this first one. So if you're not writing all of this, you can simply, by comparing the two, say that if one of these two is the answer, then answer has to be the second one, import by US from France, and not this one. This is obviously smaller. How much is this? 6.5 into 2.5, and this is how much? This is 6 into 5, 30. This is 30, and this is how much? 6. This is less than 20, right? So that is the reason that you do not need to calculate everything. Anyway, exports by Japan to UK. Now I'll not read it like this. I would just think of it as imports by UK. The way these first two options are written, imports by UK from Japan, because everything is given in terms of imports only. So imports by UK from Japan. So where is UK? UK is this. From Japan, Japan is this yellow one. So UK, Japan, how much is this? This value is 6. So this again is 6, and this is again UK, which this black bar, black, and where do we have to go? Japan, black, Japan. So this is the value. This is 40% again. So this is 6 into 100 by 40. Let me just write all 4 of them. Exports by France to Japan, or you can say imports by Japan from France. So Japan and France is this red one. So this is how much? You can see that this is 3 billion US dollars, right? So this is imports by Japan from France. So this is 3. And what is the rate? You look at Japan is this yellow one, and France. So this is the rate here, 10, 20, 30. Japan is yellow bar because Japan is importing in this case. So Japan, yellow bar, and you're talking about France. Fine. So import by Japan from France. So yellow, this, and this is France. This is how much? This is 10, 20, 30 into 100 by 30. Now, as I said, you do not need to, these are simple calculations, but you do not need to calculate. You just have to compare. So if you look at this value, for example, BC, 60 and 6 into 100, 6 into 100, this is by 20, this is by 40, which is bigger? Obviously, this is bigger, much bigger, this is double. So this cannot be the answer, right? Likewise, if you compare A and B, this is how much? This is definitely much, much bigger. And A and C are close, right? A is a little bigger than C, but B is much bigger, almost double. So A again cannot be the answer. We'll not calculate. If you want to calculate, you can see that this is less than 20 and this would be 30, whatever the unit is. Likewise, look at this 3 into, this is how much? This is nothing, this is 10, and this is 30, much, much bigger again. Fine. So there is no comparison. So answer becomes option B. So what I was saying is that there is no calculation involved in this actually. You just have to read the chart carefully so that you do not end up making a silly mistake and then you can mark the answer directly without any calculations. But this is advisable that you at least write these numbers. Fine. And just read the chart properly and write these numbers, and then you can later compare. Just writing these 4 values and comparing it, and it will become very simple. They generally would not give you questions which are very calculation intensive. Let me go to the next one. This is question number 3. What does it say now? What is the trade surplus or a trade deficit of India with UK? Fine. So we are talking about now in Indian terms. So if India imports more and exports less, then it will be a deficit. If India exports more and imports less, then there will be a surplus. So we are talking about India and UK. So let's talk about India as an importer. Fine. So India as an importer. So let me just write this, India imports, so that we do not, and obviously we are talking about India imports or Indian imports from UK. where do we go? This is India, and we're talking about UK. So this black one. So India, UK, how much is the value? 5. This is all billion USD. We do not need to write. Come here, this green bar, and where is UK? UK is this. So how much is this? This green bar, and it goes here. So how much is this? This is just 20. This is 10, this is 20. Don't get confused because this point looks close to this 10. No, this is 10, 20, 30. It goes like this is 10, this is 20. So 20%. So how much would be the value? 5 into 100 by 20. So this is Indian imports, which would be equal to 25. If you want the unit, there'll be billion USD, but we are not interested because we are just interested in comparison. So this is what India imports from UK. This is 25 billion US dollars. Right? That's the value of the goods. Right? Now, if you talk about what India exports, if we talk about this, what India exports, so this basically is same as what UK imports, right? So UK imports from India. India exports to US, so that's the same thing as UK importing something from India. But I have written in the form of India only because we are talking about the trade surplus and deficit of India with reference to UK. So India exports is same as UK imports. You go to UK, this is UK, and where is India in this? India is this green one. So UK, India is this. This is the level. How much is this? You can check this here, right? This is nothing but 3. What would we write here? This is 3. Right. Come here again. UK is the importer, and here India is the exporter. So this black bar or black line. So this is the black one. Where is India? India is here. So how much is this? This is 10, 20, 30. The rate is 30%. So 3 into so this is 10. Fine. So you could have written it like this is UK exports and India imports, whatever. Just follow one methodology. So India imports, we looked at this India directly in these two charts, and India exports, we looked at UK imports, right? As I already explained. So these are the exact numbers. This is 25 billion USD. This is 10 billion USD. Question is, what is the trade surplus or trade deficit of India with UK? Now, who is importing more? India is importing more. Fine. So India has a trade deficit. For a surplus, you have to export more and import less. So this is India is importing more and exporting less. You should know that otherwise as well. Otherwise, it was written in the stem of the question as well. So how much is this? This is 25 minus 10. This is 15. 15 is there both in deficit and surplus. What do you need to know? That if India is importing more and exporting less, it's a trade deficit. So answer would be 15 billion USD deficit, which is option B. Just be careful with it. Nothing else is needed. Had the language of the question be what is the trade surplus, trade deficit of UK with India? So answer would have become 15 billion USD surplus, right? So whatever is the deficit for India becomes the surplus for UK. If one is exporting more, the other country, in a pair of countries, the other one is importing more. So here India is importing more, so UK is exporting more. We just had to calculate this value. Got this? This is again not much. This is pretty simple. And let's look at the last one. Among France and UK, who have trade surpluses with US? Now both have to be compared with US. So this question is very similar to this one. Here we had to calculate the exact value, and in this case we do not need to compare the exact value. We just have to find if it's a surplus or a deficit. So I'll just divide this into two parts. Let's first compare France with US. So I'm doing it like that, France, and then you can say that this is imports and this is France exports. And here I would say UK imports and UK exports. You can just do it like that. We have to just compare and see which is bigger. When we are talking about France imports, France exports, this is with reference to US only. France US is one thing that we have to check, and UK US is another pair that we have to check. The two pairs are France US and UK US. So France imports from US. This is the first thing we'll check. France imports from US. We'll go here. France, where is US? This blue one. So France, where is it? This is, you can see this here, between 5 and 6. So this is 5.5 basically. So this would be equal to 5.5. Now let's look at the rate percent. So France, and when France imports from, France is this red one, imports from US, what is the percentage? You can see this is in between here, this point, not very clear because of overlapping of, no, but this is how much. This is clear that this is 30%, 10, 20, 30. You can see where this red one is ending. This is 30%. All of them are multiples of 10. You cannot assume it to be 28 or 30. So obviously is exactly 30%, has to be exactly 30%. So what would be the total value then? 5.5 is 30%, right? So what would be 100%? So there will be 5.5 into 100 by 30. So this is the total worth of the imports by France from US. Now exports by France into US. Now if you have to check exports by France into US, what would we look at? We'll look at US as an importer, right? So US is an importer and France is an exporter. So US as an importer is here, and where is France? France is this red one. So US, France, red one, this is 6. What would we write here? We'll write this 6. And then come to this part, US as an importer, this blue bar, and where is France? France is this thing. How much is this? This is 10, 20, just 20%. So 6 into 100 by 20. So these are the values. Now you can very clearly see which one is bigger. 6 into 100 by 20, this is 30, and this is how much? 3. This is definitely less than 30, and this is definitely less than 30. So who would win here? This would win. So we are talking about, we just wanted which one is more. So if France is importing less and exporting more, and in comparison with US, we're just talking about in this left part, left division, between France, the relation between France and US. So France, the import value is less and the export value is more. That's why I said this is the winner. So it means that France case, this would be a surplus. And exports are more to US as compared to imports by France from US, right? Likewise, we'll do it for UK as well. Now the comparison would be between UK and US. So UK and US. Let's first talk about the imports by UK from US. So where is it? This is UK here. This is UK. And in UK, what would you look at? US. This is this blue one, UK, US. How much is this? You can see that this is between 2 and 3 here. This is 2.5. So what would you write? This would be equal to. Now look at the rate of tariff levied by UK on US goods. So UK is this, where is it? This black one, and US goods is this. How much is this? You can see this point exactly. This is clearly 20%. So into 100, 20, right? And let's come to this part. Now these are UK exports to US. So UK exports to US. So who is the importer now? US. So US is the importer. Come to this part again. This is US, and the goods are coming from UK. So under this, look at UK. Where is this UK? Black one. So under US, black one. How much is this? This is 3. And now US is the importer. So again, come to this blue bar US from UK. So this is blue and this is UK. So if goods are coming from UK, how much tariff or what percentage of tariff, import tariff, would be levied by US? It is this dot. How much is this? It's 10, 20, 30. Or you can do this like that, 50, 40, 30. So this is 30% basically. So this would be 3 into 30. These are clear values. This would be 10. Because these are integers, we can just write them. This is into 5, so this is 12.5. You can clearly see that this is going to win here. So what does that mean? In this relation between UK and US enjoys a surplus and UK experiences a deficit here. So UK imports more when the comparison with US. So what is this then? This is a deficit. So this is a deficit for UK between the UK US pair. If we talk in terms of US, then US enjoys a surplus with UK. You can say that. The language of the question was among France and UK, who has or who have trade surplus with US. So France, because it exports more to US, it has a surplus, and UK because it imports more from US as compared to this UK exports to US, it has a deficit. So what would be the answer then? Answer would be only France, which would be option A. So as you saw here, this question was not difficult. In fact, if you look at it, with DI, people would generally associate calculations and all. Where are the calculations in this? There are no calculations. You just had to read this chart carefully. And just that. And they had given you examples in that chart, which ideally should ensure that there are no mistakes in this. But you just had to pick the values neatly, carefully, and write them down. I mean, I would not mind if you, in a question like this, write the values properly like this, because you would not want to make a silly mistake in an easy question like this. This was doable. You just had to pick the values from here, and then it becomes very simple. I mean, the calculations are such that, look at these numbers. The values are such that you actually do not have to do anything here. For example, this comparison here, 6 is bigger than 5.5, and in the denominator 30 is bigger. So obviously, even the comparison of ratios is like quite simple here, and could have done it quite easily. Right, so this is where I'm going to close the session. I hope you found it useful. I'll see you again soon. Goodbye. Hi friends, let us discuss this Lrdi set that appeared in slot 1 of CAT 2025. If you have not attempted this, I would advise that you try doing it on your own first and then look at the solution. Let's see what it says. At Innovatics, 6 employees A, B, C, D, E, F were spread in 2 groups of 3 each, Elite led by manager Kuku and Novus led by manager Lalu. Simple data. At the end of each quarter, they handed out ratings to all members in the respective groups. In each group, each employee received a distinct integer rating from 1 to 3. So the situation is like there are 2 groups, 3 people each in each group, and the ratings would be different. So no 2 people would get the same rating, and the ratings are 1, 2, or 3. Again, very simple. And the score for an employee at the end of a quarter is defined as their cumulative rating from the beginning of the year. Right, so the score would be different from rating. So if somebody gets a rating of 3, 2, 1 in 3 quarters, then the score would be at that particular stage sum of 3, 2, 1. It's like that. Again, pretty simple, nothing much. At the end of each quarter, the employee in Novus with the highest score was promoted to Elite, and the employee in Elite with the minimum score was demoted to Novus. Okay, so there'll be 1 employee moving from Elite to Novus and 1 from Novus to Elite. So elite is elite, so it's the higher group, you can say something like that. So the one who performs the lowest, or whose performance is not good, the worst among the 3 would be demoted to Novus, and the one in Novus whose performance is the best is promoted to Elite. Simple data again, not much to remember from this. And if there was a tie in scores, the employee with a higher rating in the latest quarter was ranked higher. What would that mean? I'll just show you. So for example, if the situation is like this is somebody getting 2, 2, 2, and somebody else who gets, like that. So this is, let's say, 3, 2, 1 in this particular order. So both have a score of 6 after 3 quarters. That is the meaning. Then in that case, who would be ranked higher? This guy, 2, 2, 2. Why? Because in the latest quarter, just read this, the employee with a higher rating in the latest quarter. So I'm assuming, or we'll take it like that this is the first quarter, this is the second one, this is the third one. In the latest quarter, who is ranked higher? This is 2. And so this guy got a rating of 2 and this guy got a rating of 1. So in that case, this performance would be considered superior to this performance, right? So that is the meaning. This is again pretty simple, not much difficulty here, right? So this data is not much, and then this is followed by a few statements. Okay, let's just before, and it's like very obvious, we'll have to tabulate all this. let's look at the kind of questions it's asking. What was Eklavya's score at the end of quarter 2? How many employees changed groups? What was Bunty's score at the right? So this is pretty obvious that you'll have to tabulate the data and then only we can answer the question. So what I'll do is that I'll just remove these questions, they're not really required, and create a small table kind of a structure in which we can put the data over here, right? So what we can also do is that you can understand what I intend to do here. So I'll just create two groups. So it is, this one is elite, fine, and so that there is no confusion, I'll write the name of the manager as well. So this is Cuckoo and this is Novice, and the manager is Lalu. So it is like that, right? And these rows are for phases. So it says there are quarters rather, fine. Okay, at the end of each quarter. So if we look at this, I'll just put it like that. This is 1, this is 2, this is 3, and this is 4. And so these are quarters. It is simple, right? Okay, what does it say? A, B, C were in elite at the beginning of quarter 1. All of them were in novice at the beginning of quarter 4. Now it's very obvious that each group, this elite and this novice, would have three people each. Now, which 3 is the question, right? So for the first phase, for the first quarter, it says at the beginning of quarter 1. So you can just assume here that whatever we are writing is for the beginning of a quarter. So this 1 here, this row denotes the people who are in elite at the beginning of the quarter 1. So here we'll write beginning of quarter 2 like that. Now it's given here that ABC were in elite at the beginning of quarter 1. So here we can write ABC. So this is A, this is B, and this is C. If they are in elite, this group at the beginning of quarter 1, who would be here? The rest 3, fine, D, E, F. So it's not written here, it's obvious. So we'll just write this as, this is T, this is F. And what we also know is that since one person after every quarter is demoted, so one among ABC is going to go to this side at the beginning of quarter 2, and one among these 3 is going to come here. We know that this change happens only for one person. So it's like one person is exchanged between the two groups, simple data. Now this statement, if you look at this, all of them means ABC only, Asha, Bunty and Chintu. They were in novice at the beginning of quarter 4. So yahan par this quarter 4 would have ABC. So we can just write it so ABC, and this would be D, E, F. Fine. So it is like that. And what we do not know still at this stage is the ratings. Fine. So we know that in quarter 1, lead group had ABC and this novice group had DEF with manager Lalu. This had manager Cuckoo, right? But the ratings here are not given. That's all right. Okay. And statement 2 says D and F were the only employees who got the same rating across all the quarters, but nothing much is known. We know that D and F were these 2 people. And the following is known about ratings given by Lalu. Now Lalu, when we write it like this, so it helps in the way that, now you know that this is novice Lalu. We are talking about ratings in this group. When in quarter 1, different people, in quarter 4, different people, but we are talking about ratings given in the novice group, ratings given by Lalu. Bunty received a rating of 1 in quarter 2. Now, if Bunty received a rating of 1 in quarter 2, we are talking about this. This is the group, elite group in quarter 1 at the beginning of quarter 1. So this is quarter 2. So if Bunty received a rating of 1 in quarter 2 by Lalu, it means that Bunty would be here. So it means what we know is that from ABC, who was the one who must have got demoted in quarter 1 or after quarter 1? If Bunty received a rating of 1 in quarter 2 by Lalu, it means that Bunty must be in this group, Lalu's group, which is novice. So Bunty should be here. Well, this is Bunty. And what we also know is that Bunty should be here. I'm not writing anything else. I just know Bunty is here. So Bunty must have come here. Now, since only one person can go out of this elite, and it's just one person exchange happening every time. So I can say that A and C would retain their positions in the elite group even in quarter 2. So I'll just write this as This is A and this is C. And what must have happened? These A and C must have been joined by one of these three here, right? We don't know who, but let's just read further. A and D received ratings of 1 and 2 respectively in quarter 3. Now this is also the ratings given by Lalu only. So what we know is that it's talking about A and D. A and D received ratings of 1 and 2 in quarter 3. Now here in this case, one thing is very obvious. Since these three, A, B, C, all went to novice, so it must have happened like this, that here we know from 1 to 2, B moved here, then A must have moved here, then C must have moved here. And so what we know is that once somebody changed the group, the person was never able to come back. Do you get the point? So it can happen. The question permits that. Then one person moves from one group to another group, but then it can the person can come back again. But here in this case, since A, B, C, all of them move to novice, and D, E, F, all of them move to elite, the only way it can happen is, just think about it logically, is that the person who is transferred to another group never comes back. That is the only possibility. So for example, from ABC, B comes here, right? And this is the beginning of quarter 2 and this is the beginning of quarter 4. So B is here and A and C are still here. But at the beginning of the quarter 4, ABC, all of them are here. How can this happen? Among these two, A and C, one must have moved to novice at the beginning of quarter 3 and then another one moved to novice at the beginning of quarter 4. So one came here, then another came here, then another came here. It must have happened like that. So there is no case possible here in which a person changes group and then comes back to the original group. So that cannot happen. Now we can make use of this fact or this logic to determine who moves when. Let's read it again. Asha and Dolly received ratings of 1 and 2 respectively in quarter 3. So A and D in quarter 3. So it means what? We are talking about ratings given by Lalu. So it means A and D were definitely in this group and B is already here. As we already proved, as we already figured out, that B cannot come back here. That's not possible. Otherwise, B comes here, then goes here, then it'll just break this chain. This is not possible. So it means B along with A and D must have been here. That's the only possibility. So I'm just writing like that. Who are they? A and D. So it must be like that. This is A, right? And then B. This B would retain the position, and then this D. So I have written them in this order so that you understand what's happening. This D was originally here. So even at the beginning of quarter 3, D was here only. So D moved in the end, right? Here at this position. In quarter 3, D was still with Lalu's group, novice. But D eventually moved here. So one by one, they all moved, right? But this B, since he had already moved to novice, Lalu's group, in quarter 2, he would remain here. So B would be here in quarter 2 and would still be in this group in quarter 3 as well. And A and D would also be there. So we know the exact composition. So this would be ABD for this group, and likewise then we can write the 3 letters here as well. So what would they be? A and B have moved here. This is C. So this becomes C here, and this would be E and F. Right. So it must have happened like that. And what we also know is that if you look at this, D and F were the only employees who got the same rating across. Okay. And we can write their ratings as well. A and D got 1 and 2. So this is 1 and this is 2. And what we can also write here is that since this is D 2 here, D would be 2 here as well. And D would be 2 here as well. Right? It has to be like that. Which statement am I using? Second one. Dolly and Falguni were the only employees who got the same rating across all the quarters. So D, if here it is 2, by using this statement, then D would be 2 here as well, here as well. And where is D here? We'll just figure out, right? Now, if you look at this, it says D and F had the same rating. Now, one thing, we'll come to ratings. One thing that we still need to figure out is who is this, E or F, right? Now, this is D2 we can also, before doing this, we can also write one thing. If B moved here in quarter 2, what must have been the rating of B here in this case? I mean, when we are talking about quarter one, the score would be same as the rating, because scores are cumulative. But in quarter 1, whatever is your rating becomes your score. So if B was demoted from elite to here, so I mean, the movement must have happened like this, no? From here, it moved like this. So what must be the rating? That has to be 1, the lowest rating, right? We don't know who is 2, who is 3 among A and C, but B definitely must have been 1 among the 3, the lowest rating among the 3. Then only B would be demoted to this group, the lower group, the novice group, right? So this is 1, and we know that. Likewise, if we come to this is D2, E and F are still left. Now we know that for F, the rating was constant. I mean, whatever was the rating, it remained the same. Now this is D2, and we need to figure out who among E or F moved here, right? Because at this stage, E and F both are here, but one must have moved first, no? Now, who is it among E or F? We still don't know that, right? So for that, what would we do? We know that here in this group in quarter 2, this is B fixed, and then, you know, it would be D, because D is here, so D would definitely be there. I mean, I can just write that here as well. This is D, and we can write 2 as well. You got the point? Because D was here in quarter 3, so D must have been here in quarter 2 as well. The only thing is that who is here, E or F, and who is here, E or F. So for that, what logic do you use? Now this one of them is 1 and 1 is 3 in terms of ratings. 1, 2, 3. This is D2. So either 1 or 3, and accordingly then 3 or 1. But for F, the condition is that the rating of F remains constant. Now, if the rating of F remains constant, F would never be able to move to this group, the elite group, if the rating of F is 1. So I'll just show you what I'm saying. If this is 1, for example, the ratings are distinct. If this is 1, then this would be 3, and accordingly we can then move. But if we put this as 1, fine, in the second round also, or in the second quarter also, would this be 1, then 1? So how would someone who keeps getting 1 be promoted like that? Another logic can be that if you look at this F1, and F1 means he'll not be able to move to this other group, the elite group, E would go. It would be like this. So E would get promoted here, E comes here, and F would remain here. Now just look at this, what would happen? Now can you see that B is already at 1 and F would also be at 1, and you can use this. This is even simpler, right? So if I give the rating of 1 to F in quarter 1 in this group, novice, Lalu's group, then F would be stuck at 1, but B is 1 in quarter 2. So we'll have 2 people with the rating of 1 here. B already at 1, which was given here in the statement, and then F also at 1. So what that means is that this is incorrect. This is incorrect. This is incorrect, and this rating that we have assigned to F as 1 is incorrect. So there are 2 possibilities only. Either F is 1 or F is 3. So what is the possibility then? Then it would be exactly the reverse. So it would be like that. This would be 3 and this would be 1. And if this is 3, this is 1, what would then happen? If you look at this, who would be promoted then? If E is 1, F is 3, then E would remain here and F would be promoted. So F comes here. So I'm just writing this here. So this becomes F. And now since we have reduced the rating of F here, which is 3, it would be 3, 3, 3 everywhere. So I'm just writing this as 3. This is 3, this is 3, and this is 3. So this becomes 3, 3, 3. And here this becomes E. It becomes like that, right? So F moves first and D moves in the end. And here in this case, E must have moved here. And we know the rating of E as well. It's falling in place. This is 1, this is 2. Then what is the rating of E here? 1 gone, 2 gone. So this has to be 3. And this is all logical. You can see that. I mean, if you look at the scores here, B, D, E, what are the scores? B is at 1 plus 1, 2. D is at 2 plus 2, 4. And E is at 1 plus 3, 4. So if you look at this, B is ruled out. Among the 3, I'm looking at who would be promoted to this group. So if you look at this, B has got just 1 plus 1, 2 score. And this is D, 2 plus 2, 4. And E is also at 4. But why would E come here and not D? Why would E go there? Because the latest rating of E is higher. So E is at 3, fine, and D is at 2. The sum or the score of both of them is 4, 4. Which two? D and E. B is lower. B is at just 2. 1 plus 1, 2. So among D and E, E would be promoted and would come here in quarter 3 because the latest rating of E is 3, whereas D is 2. 1 plus 3 is 4, and this 2 plus 2 is also 4. But the latest rating ensures that E moves here. So now everything falls into place and we've got the exact numbers. We have filled F as 3 everywhere, D as 2 everywhere, and this is all known to us. We can fill this B as well. This is 2, 1, and this becomes 3. So these are all concrete numbers and we have to fill this part up. This is 2, 3, we can fill this 1 already. Now let's just try filling the rest of the data up. These are the ratings left. We already know the people in the respective groups in all the 4 quarters, right? So let's start with this quarter 1 only. This is A and C left. 1 is already gone to B. So it can be 2, 3 and accordingly 3, 2. So I'll just make 2 cases like that. I'll say this is 2 or this is 3, and accordingly then this would be 3 or 2, fine. So this is right. What does this notation mean? If A is 2, then C would be 3, and if A is 3, then C would be 2, written in this order. Now let's see what happens. What we know is that let's first try and figure out what are these values A and C. F is gone, this is 3, so they would be among 1 and 2 only. So one of them would be at 1, the other one would be at 2. Then we'll figure out for this. Now if you look at this quarter 3, who goes out or who is demoted from elite? So if you look at this here, A goes out, fine. C goes out, but C goes out in the end. C from here to here, the demotion happens. So in quarter 3, so the score would be compared after quarter 3 performance and then C goes out. But who goes out first or who is demoted first among A and C? You can see that it's A clearly. Here you cannot see C, but you can see A, right? So A was demoted first after quarter 2. Now look at the scores. Let's first check for A2 and C3. What are the options here? 1, 2. If A is at 2 and C is at 3 and I just put them like that, let me just check. If I say that it's like that, this is 2, this is 1, what would happen if you put it like this? So what would be the score? Score is the cumulative rating, nothing else. Then A would be 2 plus 2, 4, and C would be 3 plus 1, 4. Fine. So the scores would be equal, but in quarter 2, A would have a higher rating. Fine. You can see that. So that condition of recency, when if there was a tie in scores, the employee with a higher rating in the latest quarter was ranked higher. It means that if we allocate A rating of 2 here in quarter 2 and C a rating of 1, who would go out? C would lose and C would be demoted, but that's not the case. It means that this has to be 1 and this has to be 2. No other possibility. If we take the rating of A in quarter 1 as 2 and C as 3, right? Look at the other case as well, just to check what will happen here. If this is 3 and this is 2, fine, A is 3 and this is 2. So in that case, A has to go out. It's very clear that if we assign this rating of 2 here and 1 here, this is not going to be possible. Just look at what I'm saying. A has got a rating of 3 here. I'm now looking at the second case. A has got a rating of 3. I mean, it's very cumbersome to make another table. So you can put some small data in the same table. So if A is at a rating of 3 and C is at a rating of 2, and now again A gets 2 and C gets 1, what would be the score of C? This 2 plus 1, 3, and A would be at 3 plus 2, 5. Who would go out? C. Not possible. It means that in both these cases, when A is 2 and C is 3, and the second case in which A is 3 and C is 2, we have to put the rating of A as 1 and C as 2, and only then A would be demoted, otherwise C would be demoted. So we can correct that. We can say that this is not possible, what is written, right? And it has to be exactly in the other order. So it has to be like that. This is C. Now you can see what will happen when it's very clear. If this is 2, 2 plus 1, 3, and this is 3 plus 2, 5. So A would go out in the first case. Look at the second case, A3, A1. So this is a total of 4, and C2 and C2. This is a total of 4. But who would go out? Because of that recency factor, again, here C2, A1, so A would go out. So both the cases it's satisfying. So now I've got two cases here. In both the cases, A is demoted after quarter 2. So no problem. But we still have to check if they are consistent with the ratings of C and E. Now what would happen in case of C and E? What we know is that among C and E, F is going to be here. F is at 3. F is the boss, so it'll be here. Among C and E, who goes out here, or who is demoted from elite to novice in this case? So this is 3. This is C, E, F. This is A, B, C. So C goes out. So among C and E, we have to check now. Now look at their scores. E is carrying the cumulative rating of 1 plus 3, 4 when E comes here. So whatever E gets here plus 4 would be the score of E. You get this? 1 here, 3 here, and whatever E gets here, 1 or 2, right? And likewise, C would be carrying a cumulative rating of this 3 here, this 2 here, and this 2 here, or 2 here, and 2 cases. So let's look at the first case. If this is 3 and this is 2, fine, and we allocate it like that. Fine. 3 is gone, so we have to allocate either 2 or 1. If we do it like that, who would go out? Just look at this. This is 3, this is 2, this is 2. So C, the score would be 7. And what is the score of E? 1 plus 3, 4 plus 1, 5. So in that case, E is going to go out or going to get demoted, which is not true. It means that this is not possible. Let's check the second case as well. Now in the second case, C is at 2. So this is 2, 4, and this is 2, 6. I am working under the assumption that C is allocated a rating of 2 here in quarter 3. So the score of C would be this 2 plus this 2 plus this 2. So this is 6. And where would E be? 1 plus 3, 4 plus 1, 5. Fine. Can you see this? 1 plus 3, 4 plus 1, 5. So in that case also E goes out. So whatever way you look at it, E goes out if we allocate C2 and E1. In the second case, this is 2 plus 2 plus 2, whatever way you look at it. In the first one, the bottom line is that E is already at 4 plus 1. This is 1, this is 3, fine, 4. So if we give E a rating of 1 here, the way it's written here on your screen, so E ends up with a score of 5. And C, if C gets a 2, C in any case is not going to end with a score of less than 6. Can you see that? Because this is either 2 or 3, this is 2. So either 4 or 5 from here and then another 2 from here. So this would be either 6 or 7 for C. You can see this. Just look at my pointer. So either 6 or 7, and E would be only at 5. So E is going to go out, which is not true. It means what? That what we have written here is incorrect. This is not going to happen. Fine. This is incorrect. So what is the only other possibility? 3 is gone. So it has to be the reverse. So this C has to get a 1 and E has to get a 2. Then only it's possible. And we'll look at if this is actually working or not, because there are two cases. So we have to figure out if both are correct or not. Now you check what will happen if this is 3, this is 2, this is 1, this is 6. 3, 2, 1, 6, and E would also be at 6. But who would go out? C. C would be demoted. Why? Because the recency factor, E would be placed higher, C goes out. Look at the second case. C is at 2, then 2, and then 5, and E is at 6. So 5, 6. So E is retained here in the elite group, and C would be demoted to novice. So in both the cases, when C is 3 and when C is 2, this works. One, because of this recency factor, this condition. Other one, it's clear. E is at 6, C is at 5, it works. When both are at 6, then we look at this condition, because of which also C would be demoted. So it's all satisfying then. So this is the final configuration in which we have got two cases. All this is concrete, but here A can be 2, and in that case C would be 3. If A is 3, or A has got a rating of 3, then C would have got a rating of 2. So we could fill this up completely. We just don't know about the final ratings or the quarter 4 ratings of ABC. We could fill this up because we know that D and F got the same thing. It's D and F were the only employees who got the same rating across all the quarters. That's why we could fill it up. It's not really required here. So this is our final table, and with which we can answer all the questions. Let me just show you the questions now. What was E's score at the end of quarter 2? E's score at the end of quarter 2. So this is quarter 2. So it would be 1 plus 3, 4. Simple. score would be the sum, cumulative rating. How many employees changed groups more than once up to the beginning of quarter 4? Nobody changed. When this is one question that we could have answered without actually solving everything. So once somebody moved to the other group, they could never come back. You could answer the second question even by just looking at the data in the beginning, which said that ABC started here, ended up here. Since one person only moves either demoted or promoted, we could have said that nobody changed it twice. So the answer would be 0 here. And what was Bunty's score, B score at the end of quarter 3? At the end of quarter 3 here. So this is 1, this is 1, 1 plus 1, 2, plus 3, 5. So this becomes 5. For how many employees can the scores at the end of quarter 3 be determined with certainty? So if you look at this at the end of quarter 3, at the end of quarter 4, though, would be difficult because this is not known. At the end of quarter 3, we can answer for B, we can answer for D, we can answer for E, we can answer for F. But for A and C, we cannot answer. Why? Because they can change positions. You can see that A can be in quarter 1 at 2 or 3 and accordingly. So for A and C, we cannot determine. For B, D, E and F, we can determine. It says scores at the end of quarter 3. So we'll just look at till this stage. This quarter 4 would not matter in that case. So answer would be 4 in that case. B, D, E and F. A and C, we can see we cannot determine. So it becomes 4. And with the following statements is are necessarily true. A received a rating of 2 in quarter 1. A received a rating of 2 in quarter 1. No, it's not necessarily true. A received a rating of 1 in quarter 2. 1 in quarter 2. This is true. So this is always true. This may or may not be true. The question is which of the following statements are necessarily true. So necessarily true, only 2 by B. This is not false, the first one. This is just one of the cases. But A could have got a rating of 3 as well in quarter 1. So that's why it's maybe true, not necessarily true. Only 2 is necessarily true. Answer would be option B here. Right, so this is where we close the session. This was a good question which again required a logical approach. And if you could, just work on it accordingly rather than trying to apply the brute force, you could have arrived at the solution quite neatly. It's not very tedious that way. Right, I'll close the session here. I'll see you again soon. Goodbye. Hi friends, let us discuss this LRDI set that appeared in slot 1 of CAT 25. If you have not solved this, you would want to give it a go first and then look at the solution. If you've done it, let's see what it says. Alia, Badal, A, B, C, D, E basically played a game in which each asked a unique question to all the others and they respond by tapping their feet either once or twice or thrice. Simple data. 1 tap means yes, 2 means no, and 3 taps means maybe. A total of 40 taps were heard across the 5 questions. Simple again. Each question received at least 1 yes, 1 no, 1 maybe. So this yes would mean 1 tap, this no would mean 2 taps, and this maybe would mean 3 taps, right? And this is obvious because there are 5 people here. Each question would be answered by 4 people. Why? The one asking the question would get a response from 4 others. So if Alia asks a question, the response would be given by B, C, D, E, Badal, Clive, Dilshan and Ehsan. This is how it's going to work. And some information is given. Now, if you look at this, and it does not look like too much data. This is all given here. And before answering the question, we should always have a brief look at the questions. So what does it say? How many taps did Clive receive for his questions? Which 2 people tapped? So it's pretty obvious looking at this that we'll need to tabulate this whole thing. And then we can answer these questions. So what I'll do quickly is that I will, just remove these questions from here, and we'll try and put this data in the form of a table. So these are responses that can go here, and these would be questions. So if Alia asks a question, I'm putting this A here. Fine. So when Alia asks a question, 4 people would respond. So if I put this A, B, C, D and E here, what would that mean? So this is the row of questions. So Alia asks a question, then Alia asks a question. Alia would not respond to that question. The rest of them would. So I would keep this as blank, and these B, C, D, E can respond in yes, no, maybe, right? So one tap, two taps, or three taps. There are three options. Now, if you look at this statement one, it says Alia tapped a total of 6 times and received 9 taps to her question. So can I say this response to Alia's question would be given by, since these four people B, C, D, E, this total would be 9. Whatever numbers appear here, this number, this number, this number, this number, the total would be 9. Why would this be 9? This number, this would be 9 because these responses can be in the form of yes, no, maybe. So if B responses in a yes, it'll be 1. If B responses in a no, 2. I'll put a 2 here. Maybe I'll put 3. And these responses that translate into taps would add up to 9, as is written here. Alia tapped a total of 6 times and received 9 taps to her question. So this row denotes Alia's questions. Response given by B, C, D, E, and these responses when translated into taps would add up to 9. So that is the exact meaning. And it says Alia tapped a total of 6 times. Now this column would denote Alia's responses. So these are all the responses. So I can just complete this table and I'll put it like this. Now this is self-explanatory. What would this mean? This is the question row of B. This for C, this for D, this for E. And this is the response row. These are all the response, rather columns for A, B, C, D, E. Now, when it says Alia tapped a total of 6 times, when would Alia tap? Alia would tap only when Alia is responding to somebody else's question. So what would this cell have? When B asks a question, Alia would respond. And so if it's a yes, then we'll write a 1 here. If it's a no, then 2. If it's a maybe, then we'll write a 3 here. So likewise, these 4 cells would add up to what? It would add up to 6. Why? Because Alia tapped 6 times. So I'll write a 6 here. This should be simple. Now this format and all is fine. So these are the responses. Yahan par, all these 4, B, C, D, E, they would be the responses to Alia's questions. The number of taps add up to 9. And these 4 cells would be the number of taps corresponding to the Alia's responses to the questions asked by B, C, D, and E respectively. And this number adds up to 6. So this is given here and we can just do it like that. So what we'll first do is that B would not respond to B's questions. So I can just say that. The structure of the table should be very clear. So for example, in this cell, what would be put? This would be the question row of D. And in this cell, we'll put the number corresponding to the response given by B to D's question. Look at this cell. So this is the response of B. B appears here and this is the question of D. So in this cell, if B responses are maybe to D, then we'll put a 3 here. Likewise, we can continue. Now we can just plug in the data from this, from these statements given here. What does it say? If you look at this, A responded yes to the questions asked by both Clive and Dilshan. So C and D. So A responded to C and D in a yes. So this is the response of A, C and D in a yes. So what does that mean? Yes would translate to 1 tap. So this is 1 and this is 1, right? Like that. So this 1 plus 1. Now what would be left here? This is a cell left. This is a cell left. This is 1 plus 1, 2. 6 minus 2 would be 4. So the sum of this and this would be equal to 4. We know that, right? Let's just fill up the rest of it. D and E, I'll not use their full names now. Tapped a total of 11 and 9 times respectively. Can just put it directly here. D and E. So D is this. When would they tap? When they're responding, right? So D and E, 11 and 9 times. This would be 11 and this would be 9, right? And D responded no to B. So D responded no to B. This is B. So D responded no. No means 2 taps. It's given here, right? So I'll write a 2 here. When writing a 2 here, since 11 is a pretty large number, you can clearly see what would appear here, here, and here. Now this is 11 and 11 would be the sum of this cell, this cell, this cell, and this cell. So 11 minus 2 would be 9. Now what is the highest that we can put in a cell here? 3. Or maybe, right? We cannot put a 4 or a 5 here. There are just 3 options, 1, 2, 3, right? So if this is 2, 11 minus 2 is 9. So 9 has to be distributed like 3, 3, 3. There is no other option. So I just put a 3 here. This is a 3 here. And this is a 3 here. So we completed this row like pretty quickly. Okay. And we have done this. B, D, and E received equal number of taps to their respective questions. So what I'll do is I'll just, so that we don't forget it, I'll just quickly X here. What does that mean? Whatever this number is, because they received an equal number of taps. So this is the number of taps received by A on her questions, right? This is the number of taps. I don't know what that number is. This is X, this is X, this is X. This is what it says. BDA received equal number of taps to their respective questions. Let's call them X for the time being, right? And another thing that we can write is, that's given in the stem only, a total of 40 taps were heard across the 5 questions. So either we count this way here or here. What we can definitely say is that this number would be 40. Fine. So we can count from this or we can count from this. And so these are the taps, these are the responses columns, right? And these are the questions column. So it's the same thing, but this adds up to 40. Let's move forward. No one responded yes more than twice. Yes means one tap. So one tap cannot be given more than twice by anyone. Now, where does it help us? We can immediately see this column here. Since it says nobody responded yes more than twice, now A has already responded yes to C and D. This is 1, 1. So it means there can be no further 1 here. So we cannot put 1 here. We cannot put 1 here. Not possible. Now, if we cannot use a 1 here, you already know what is left. I mean, this cell and this cell. If you look at these two cells, they should add up to 4. 6 minus 1 is 4. So what is the only way it can happen? 1 is not allowed. So the only way it can happen is that this becomes 2 and this becomes 2. Fine. There is no other way. We cannot accommodate a 3 here. This is the only way it can happen. So we have used this statement as well in some way, partially at least. And no one's answer to Alia's question matched the answer that Alia gave to that person's question. We'll use that later to fill the table. The same was true for Ehsan, right? And number 6 is Clive tabbed more times in total than Badal. So Clive, this is the response column, and so this number has to be greater than this number, right? So this cell, whatever is the number, read again. Clive tabbed more times in total than Badal. So whatever comes here, the sum of these 4 cells would be greater than the sum of these 4 cells. So this would be greater. Let's add them up. Let's see if we can get something. 11 plus 9 is 20. 20 plus 6 is 26. So what is left here? This is 40 in all, and these 5 numbers should add up to 40. Likewise, these 5 should add to 40. So 11 plus 9, 20 plus 6 is 26. So 40 minus 26 would be 14. This is 14 and C is greater than B. So, I mean, if they are equal, they would be like 7, 7, 14, but they cannot be equal. This is not possible. So what is the first possibility? You do not have to make any equations or anything. Can I say the first possibility is this, that this would be 8 and this would be 6? There's no other possibility. We can, think of further stuff like 9, 5 and all, but this is the first possibility. Now, this has to be the only possibility here. The reason is that when we were doing the column for A, we realized, because of the statement that no one responded yes more than twice, that if we have to minimize the sum for any column, the least possible value is 6 only, isn't it? Because 1 cannot appear more than twice. If I have to, these are 4 responses, right, for B. Now, B cannot respond in a yes more than twice. So yes means 1 tab, like this, like this. So 1, 1, 2, 2 is the lowest total. I'm just showing it to you separately. If I'm saying everybody has to respond 4 times, right? So the responses of B, if I'm saying I need to minimize the number of responses or the taps for B. So the responses have to be what? Yes, yes, no, no, because maybe it would give you a 3. So even this minimum number of taps would be 1 plus 1 plus 2 plus 2, which would be equal to 6. And here, this condition, which is given in statement 6, Clive tapped more times in total than Badal, is satisfied for 8 and 6. So we cannot think of stuff like this, 9, 5, fine. 7, 7, they are equal. So I'm saying in place of making equations, you can just do it by observation. So 7, 7, they would be equal. So the first possibility is 8, 6. So 8, 6 is okay because 6 can be made through 1, 1, 2, 2. But if I say something like 9, 5 or 10, 4, this would not be possible because the sum of all these 4 cells in a column cannot be 5. For it to be 5, it has to be 1, 1, 1, 2, which is not possible because 1 cannot appear more than twice, as we saw in column 1 and as is written in statement number 4. So what does that mean? These numbers are also concrete. This would be 6 and this would be 8. So let me just write them properly. So this becomes 6 and this becomes 8 here, and we can just remove this. Likewise, now since we know this is x, how much is left here? This is 40, this is 9, so this would be 31. Fine. What is 31? I would say if I call this as, let's say, y, for example, so what would this be? 3x plus y. You don't have to make an equation, I have just am showing it to you. This would be equal to 31, right? If this is 31, you tell me what can be the value of x. Now, what is the condition given here? Each question received at least one yes, one no, one maybe. So yes means one tap, this means two taps, and this means three taps. So it means what? If you look at each of these rows, they would have at least 1, 1, 1, 2, and 1, 3 for yes, no, and maybe respectively, right? So if you look at these totals, I mean, because for every question you have 4 responses, can I say it would be like this: 1, 2, 3, and then one other number, right? So I would say there are 3 options for this, right? The fourth one is missing. Since it says 1 yes, 1 no, 1 maybe, so the fourth response for every question which these 5 people asked would be one of these 3 only, 1, 2, or 3. So I would say these are the possibilities for the totals. Now, what is this? This would be equal to 6 plus 1, 7. This would be equal to 8, and this would be equal to 9. These are only 3 possibilities. Fine. So 9 we can see here. For A it's 9. For these 3 it's still left. Now it's very, very obvious which one would come here for x, 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 y. So for example, if I put x as 7 here, so what would it become? 7 into 3, 21, plus y would become 10. So this becomes 7, this becomes 7, this becomes 7, this becomes 10. Is 10 possible? No, not possible. So what is the meaning? That it cannot be 7. If we make it 9, fine. The only 3 possibilities for these sums, row-wise sums, would be 7, 8, 9, as I already showed. If I put x as 9, 9 into 3, 27. Y would become 4. Is that possible? No. The only possibility is that x would be 8. So it would be like that. 3 into 8 plus this would be 7. This becomes 31. That's the only possibility. So basically, I did not want to write this xy here just to explain, right? So these values here, this becomes 8, this became 8, this became 8, and this would become 7. And then this total would become 40. So we've got all these numbers as well here. So we can just remove this small equation. I'll just put it like that. So this becomes 8, 7, 8, and 8. So we've got these concrete numbers here, 8, 7, 8, 8, and now we can just work on them, right? Now you also know how would we make a 9. So for this, so for example, this 9 would be made by 1, 2, 3, 3. How it would help is that if this is 1, 2, 3, 3, you can already see that this 3 is there. So what would come in these 3 cells would be 1, 2, 3 in some particular order, if this is written over there. So you know that already, right? So you can just, with the help of this, it's nothing complicated. It would help you in just filling this table up. So for example, this is 9. When 1, 3 is already used, and this 9 would be made like this: 1, 2, 3, 3. 1, 3 is used. So what would be left? So if I just remove this from here, I can say that here 1, 2, 3 is left to be put in these 3 cells. In what order? We do not know. Likewise, we can do it for 7 and 8 as well. But 9 is special. Why? Because this is A's row, and A is already filled up. This column is filled up. So filling this row up would be easier. The reason why I'm saying this is because the statement 5 talks about no one's answer to Alia's question matched the answer that Alia gave to that person's question. What does that mean? No one's answer to Alia's question. So for example, if we talk about B, fine. So this cell would have what? B's response to Alia's question. Now this response would not match this cell, right? So these 2 cells, this is what, I mean, you can just, in place of reading this lengthy statement, you can just think of it like that. This AB cell would not match this AB cell. The reason is, what is this cell? This is B's response to A's question. And what is this cell? This is A's response to B's question. Yahi bol rahe na? No one's answer to Alia's question matched the answer that Alia gave to that person's question. So B gave response to Alia's question in this cell, whatever the number is, right? And A gave response to B's question. So this is B's response to A's question, and this is A's response to B's question. So what does that mean? If this is 2, this cannot be 2, right? So this can be either 1 or 3. But here, if you look at this, this is 6. How do we make a 6 here? 6, we already talked about in detail. 6 can only be made like 1, 1, 2, 2. So we cannot have a 3 here because 6, otherwise we cannot make a 6 here. So what we know for these 4 cells is that they would have 1, 1, 2, 2 only. If you want, we can write it here, or we can just keep this in mind. It's already written here. So in 1, 1, 2, 2, this cell can only have either 1 or 2. 2 is ruled out because 2 is here. Fine. Now we'll just remember this. If AB, fine, this AB is this 2 here, or you can call it BA or whatever, this cannot be 2. Fine, like that. This is true for A, and it says this is true for E as well. So for example, if this is AC, I mean, or CA, whatever you put it, this is A, this is C. So this number cannot appear here. Why? This is also AC. The order does not matter. Wherever it's a merging of A and C, fine, like this here, and wherever again you find A and C together like this, the number cannot be the same. Likewise, right? So this can either be 1 or 2, but 2 appears here, so this cannot be 2, so this would be 1. We can just put this as 1 here. So this 1 is gone from here, this is used. So what do we have here? This is 2, 3 only. We can again use the same logic for AE. This is E, this is A. So this is 2. If this is 2, we cannot have a 2 here. If this is not available, 2 is not available for this. If this is not 2, what are the 2 options? 2 and 3. So this has to be 3, and then 2 would come here. So this becomes 3. And this becomes 2. And what we can now do is we can say that all this is exhausted. We do not have to put anything else here. We can just remove it from here and say that this is filled. Now the statement 5 is very useful. For example, we have used it for A already. For this is exhausted, A is column and A is row. For E, if you look at this, this is E's row. So for A it's done. Look at this 3 for example. So this is ED. Now this DE we know cannot be 3, and I'm just writing like that. Fine. Why is it not 3? Because this is D, this is E, this is 3. So this DE cannot be 3, right? Both of them cannot say maybe, right? So if it's like that, the options here are just 1 and 2. Now how do we make a 8? 8 can only be made like this. This is for rows. The composition of an 8 for a row, 1, 2, 3, and then another 2. Now this 1 is already used. So what is left for this 8? 1 is gone. So can I say 2, 3, 2 or 2, 2, 3, whatever way you put it? This is left. If this is left, and we can say that this is not 3, so what is it? It has to be 2 only. There is no other possibility. So we'll just write it as 2. And what are we left with for these 2 cells now? 1, 2 is gone, and this is 2 or 3. So one cell would have 2 and another cell would have 3. But now since this total is 6, we have already used this property. We cannot have a 3 here. We cannot have 3 because 6 can only be made like 1, 1, 2, 2, the way we have been discussing. So this is the only way we can make a 6 here. So it means what? That from this 2 and 3, 3 should come here and 2 come here. But because we cannot have a 3 here. So this becomes 3, then this becomes 3, and then this becomes 2. And we have exhausted this. We can remove this as well from here, right? So what we now have is this complete D. This is 2, 3, 2, and now not much is left in this one. So if you have to just look at, so for example, this 8 now. So if this 8, how do we make 8? 1, 2, 2, 3. So this 2, 2 is already gone. So this would be like that. 1, 3, 3, 1. Right? This is the only way we can make an 8 here. Now, if you look at this, can we put a 3 in this cell? No, we cannot put a 3 here. The reason is that look at this column of C, responses of C. This is already a 2, this is already a 3. So 2 plus 3, 5. 8 minus 5 would be 3. So if we give this 3 here, this becomes 0. There is no response like a 0 here. It has to be 1, 2, 3. It means what? That among this 1 and 3, I hope you understood how is this 1 or 3? Because we can make 8 like this only. 1, 2, 3, 2. So we already have a 2 here, already have a 2 here. So what is left for these 2 cells? One cell would have 1 and the other cell would have 3, right? If you put a 3 here, we cannot make this total of 8 because 3 plus 2 would be 8 in itself. We cannot put anything here. So what does that mean? It cannot be 3, it has to be 1, and then 3 comes here. So I'm just putting like that then. So this becomes 1 and then this becomes 3. Now we can just fill everything up. This is 2, 1, 3, 3. And what would this become then? This will become 2. If this is 2, how much is this then? 3 plus 2, 5 plus 2, 7. Then this becomes 1. This total is 8. and then this becomes 1. If this is 1, what would come here? This is 1, 1, 2, 2. So this becomes again 2. And what would come here in this case? This is 7, 1, 2, 3. And what is left for this one then? This becomes 1 again. And now we got everything here. And I hope you understand how do we read this. This 2 means that C's response to A's question is no. This 3 means that D's response to C's question is maybe. You understand how to read this table. Now we can remove this as well and answer the questions using this, just this table, because everything satisfies here. Let me just get the questions on your screen. Right, so we have got the questions here. How many taps did Clive receive for his question? Clive received for his question. This is C. So Clive received how many taps? 7 taps. This is C. Clive, this is question, right? So this is the row of questions for Clive. This is 7. This is 7. So this becomes 7, which is our answer here. Which two people tapped an equal number of times in total? So which two are they? They would be these. So these are the responses. Fine. So among these 5 numbers, which two are equal? 6 and 6. So who are they? A and B. Alia and Badal will be option B. These are the responses in columns. Just remember this. And these are the questions. So this 8 would mean that B got 8 taps in response to his question, right? What was Clive's response? C's response to Ehsan's question. C's response to Ehsan's question. Ehsan's question row, this is the question row, and this is C's response. So we are talking about this then. 2. 2 would be equal to, this becomes no, right? And how many yes responses were received across all the questions? How do we know if it's a yes response? By 1. 1 tap is yes, 2 taps is no, and 3 taps is maybe. So we just have to count the number of ones in this grid. This is 1, this is 2, 3, 4, 5, 6. There are 6 such responses. So answer becomes 6. Right, so that's how we could do this. Required some work, but nothing which is too ugly, which is too difficult. You could have managed this if you had proceeded logically in this question. Right, so this is all what I had for you. I'll see you again soon. Goodbye.